So, we're going to do a video on this thing called the addition rule. The reason I'm giving you a video of this length on the addition rule is not because the addition rule is so good, but instead because we're going to dip into a lot of other areas. We're going to revise experimental probability and really, hopefully, by the end of this, you'll understand Venn diagrams a lot better, which I think are more valuable than the addition rule. But let's get into it. Okay, we're going to start with a trick question. So here we go. I wonder if you can spot which of these are, one of these are impossible to answer. So a group of 15 people on the street are surveyed about whether they listen to music on Spotify or YouTube. 5 say Spotify, 10 say YouTube, and we're asked to find probabilities for somebody listening to Spotify or YouTube or neither. Sorry, each of these. Okay, so the first thing I want to point out is that the question is talking about experimental probability. And the reason we can work out an experimental probability is because, remember, experimental probability is about data. We get some data, so some statistics, and we use those statistics to come up with a guess about the probability of something. So the question is, what is the experimental probability that somebody on the street listens to music on Spotify, for example? Now, we're only asking 15 people. We're not asking everybody on the street. This is why it's an experimental probability. You do an experiment, you take a survey, and you use that data to work out what your guess for the probability. And now it is possible that this 15 people don't really represent the people on the street. Maybe these 15 people are all in a group of really young people who use Spotify, but maybe there's a whole heap of older people who are not asked this question who use neither Spotify or YouTube. They use CDs or records. So anyway, let's go through and see if we can do these parts of the question. So what we have to do for the experimental probability is work out how many events, how many outcomes are in the Spotify event. Let's call the Spotify event S, and how many are in the YouTube event. And then divide that for each question by the total number of people surveyed. Okay, so Spotify, there's 5 people in that event and 15 in total. So it's just 5 over 15, which is a third, simplifies to a third. Okay, so YouTube would be 10 over 15, which simplifies to 2 over 3. Now these answers are both correct. The one you can't do is this. You can't work out how many are in neither. Now you might say, well, there's 5 who listen on Spotify, 10 who listen on YouTube. That means 5 plus 10 is 15. And there's no more people. That means there's nobody who listens to neither. They all listen to either Spotify or YouTube. But the problem that we're running into now is this idea of being mutually exclusive. And remember, we're going back a little bit here. Remember when we got to step 3, find out which outcomes are in which events. The problem that we had, something that made this difficult, was if 2 events are not mutually exclusive. And mutually exclusive means that it's impossible to have both. So that's the easy situation. If we had 5 people who listened on Spotify, 10 people who listen on YouTube, and it wasn't possible to listen to both, then we would say there's 0 people left. And that would be mutually exclusive. But the problem is we don't know actually how many of these 5 also listen to YouTube or how many of these 10 also listen to Spotify. So we can't work out the answer to this question. Now let me show you a better question which gives you enough information, and for this we'll draw a Venn diagram. And we're told, the key piece of information we're told here is that 3 people listen to both. So we'll put 3 people in the middle. It's always best to start off with the people who use both, and then you can, if you've got that information, and then you can put the rest in the table, so the diagram. So it says 5 people listen on Spotify. We've got 3 of them in here. That means there's 2 left. Out of this 10, we've got 3 in here, and that means there's 7 left. And so that means if I add all these up, that's 2 plus 3 is 5, plus 7 is 12. That means out of these 15, I've actually got 3 people on the outside. And now we can actually answer the question. Because 3 out of 15 listen to neither. And that simplifies to 1 over 5. 1 out of 5. Okay. Now we've just used a Venn diagram. We're going to move on to a situation where you don't have to use a Venn diagram. So before that though, I have to point out that sometimes people use the word or in probability, and what they mean by that, if somebody says, what is the probability that somebody listens to music on Spotify or YouTube, what they mean is, what's the probability of S union Y, which is this section here. So that's what the word or means in those questions. It can be a little bit tricky to work that out. Okay, so let's move on. Here is the addition rule. It's called the addition rule for complementary events. So the probability of A union B is the probability of A plus the probability of B minus the intersection, the probability of the intersection of A and B. That's really confusing. So I'll show you what that actually means in diagrams. So remember, the probability of A union B is the probability that it's in either one of these circles or in the middle. So that's what we're trying to find, and the way to find that is probability of A. Now this is the outcomes in A plus the probability of B. So now you can see we've actually got this colored section. So that's good, but there's a problem. The problem is that the part in the middle is being counted twice. We've got this, it's counted once in this part because of A, but then it's counted again because of B. So now it's counted twice. So the way we solve that problem is we take one of them away. So we subtract the intersection, and then now it's only counted once. So this is how you find the union. You add up the probability of one event plus the probability of the other minus the intersection. Okay, so this is how it works in terms of an easy example. Let's say a group of 25 people were surveyed by a farming association about whether they like oranges, which is called event O, or mandarins, which is called event M. 12 people like oranges, 8 like mandarins, and 5 like both. So what's the probability that a randomly selected person from this group likes at least one of these orange colored fruits? And so what this question is actually asking is, what's the probability that they like oranges or mandarins? And keep in mind that they could also like both of them because it says at least one of them. Okay, so it's really asking what is probability of O union M. Okay, and the way we do this, we can do this, is we can write the formula. So remember, it's the probability of one event, let's say it's O, plus the probability of the other, minus, because we have to minus the intersection, the probability of the intersection O intersection M. So what are all of these things? Probability of O, there are 12 oranges and 25 people. The probability that I choose one who likes oranges is 12 out of 25. Okay, there's 8 mandarins and 25 people. And the intersection is 5. 5 people like both. So it's 5 over 25. Now, I could simplify this last part, by the way. I could write, I could say, no, let's simplify this. That's actually 1 over 5. But then hopefully you notice that it's now harder to add and subtract these fractions because now this has a different denominator to these two. So that's not good. We actually want the original fraction, 5 over 25. And now they all have the same denominator. You don't need to simplify any of them. So let's keep going. We have to add up, and now all we have to do is add up or subtract the top numbers. So 12 plus 8 is 20, minus 5 is 15. So we've got 15 over 25, which would be 3. And now we can simplify it. 3 over 5. Okay, so in this case, the addition rule is very helpful. We didn't even have to draw a Venn diagram. That's what the addition rule is for. But some questions, I found this in a textbook and I don't really... The textbook recommended doing the addition rule and I don't think that was a good idea, and I'll show you why. So we're actually asked to find the probability of A union not B. And that's going to be tricky. And I'll show you how we would set this out in the addition rule. That's the easy part, how you write the addition rule. That's not even the hard bit yet. So probability of A union not B is you take the probability of the events and you add them up. But remember the second one is actually not B, so you have to write not B in here. And then you subtract the intersection. A intersection not B. Okay, so we're given how many outcomes are in A, how many are in B, and how many are in both A and B. The problem is this part in the end is so tricky to work out that you really need the Venn diagram to work this out, which defeats the whole purpose of this. Wasn't the reason we used this rule so we didn't have to draw the Venn diagram? So what I think we should do is why don't we just draw the Venn diagram and we'll work out from the diagram what this section is, and then we'll just find the probability straight away without using this. So let's do that. How about we try that? So I've got two events, A and B. And the first thing we do is the both section. And then 10 outcomes are in A. So we've got 7 left over here. 7 are in B. So 3 of them are in both of them. So we've only got 4 left here. And so we're trying to find... Well, okay, we'll do the last part of the diagram. If we've got 7 plus 3, which is 10, plus 4, which is 14 outcomes in here, and we've got 20 in total, that means there's only 6 left. So what is A union not B? Well, keep in mind not B is anything that's not B. So let's just let's shade that in first. And then we've also got A. So A is just this circle here. So A union not B is everything except for the 4. Oops. So that would be just the 7, the 3, and the 6. So 7 plus 3 is 10, plus 6 is 16. 16 over 20. That's actually it. So in this case, it turns out the drawing of Venn diagram is actually just a lot easier. and you don't need to use this method all the time. Sometimes if they're not telling you to use this method and you think using a Venn diagram is probably a bit easier, then just use a Venn diagram. Alright, that's it for today. See you later.